Good morning to all of you, especially to our professor, Sir Raul Urungan. I am Melissa R. Sumbilon. Today, I will show you the steps on how to run correspondence analysis in the SPSS. By the way, I learned these steps from GN Latish Kumar and get this data from his video in YouTube. Open these data sets in your Excel file, the one sent to you. And please also open your SPSS software and follow the steps. Open your SPSS software. And in the variable view, let's type, for this sample, we'll have a fragrance and product and the scores. For the fragrance, since we have 6 types of fragrance, we label them 1 for rose, 2 for jasmine, 3 for sandal, 4 for lily, 5 for menthol, and 6 for lavender. Okay, and click OK. For the product, we also have 6 products. 1 for bath soap, 2 for shampoo, 3 for baby lotion, 4 for hair oil, 5 deodorant, 6 we have face cream. Okay, add and okay. Now let's go back to data view and let's have this one. So copy here up to here, Control C to here, V 2 4 6 1 2 3 4 5 6, then 2 Control C 1 2 3 4 5 Control V, then from here up to here Control 1 2 3 4 5 6 2 4 6 and then 3 Control C 1 2 3 4 5 1 2 3 4 5 6. Let's try to get the data from here. So for the data in rows, so we'll just copy the data from the Excel file that I have sent. For the sandal, V, and then for lily, Control C again, 1 2 3 4 5 Control V, Control Z, Control C, 3 4 V, 1 2 3 4 5 6. Then the last one is lavender, 6 1 2 3 4 5 V, then 1 2 3 4 5 6. So we'll get the data from here. See, where's the menthol? It's not yet pala. Lavender. Here we have 5, 5, 5, 5. 1, 2, 3, 5, 6. So we'll have menthol. And then the last one, the lavender. So we now have this kind of data sets in the SPSS for the fragrance, the product, and the scores. Now let's do the data with cases. Assuming like that. Weight, cases by frequency, scores. Okay. Then we can now do the analysis. Date reduction, correspondence analysis. So reset. Our row would be the product. We'll define it 1 minimum value and 6 for the minimum value, since we have 6 samples or 6 different type of products. And then for the fragrance would be the column, same 1 and 6 for the maximum value, then update. And then we have this model 2 chi-square symmetrical. Okay. For the we also have to click this one, row points and column points, continue, and then plot. We have by plot the row points and column points. Okay. So click OK. So our result would look like this. We have this correspondence table. So as you can see, we have this active margin, which is the total of these rows, and the total of these columns is the active margin, or the sum of these columns. So the summary, the overview row points, the overview column points. So this is the confidence row points and confidence column points, and this the plot will look like this. So the summary table displays a variety of useful information. So in here, 4 dimensions were derived, but only 3 are interpretable, because only 3 dimensions account for a supposed meaningful proportion of the total inertial value. So the total inertial value represents the amount of variance accounted for in the original correspondence table by the total model. For instance, we could say that dimension 1 in here accounts for 27.0% of the 40.1% of the total variance. Our model explained in the original correspondence table. Stated another way, our model account for only 40.1% of the variance in the original correspondence table. And of that percentage, dimension 1 explains 27.0%, while dimension 2 has 8.60%, and dimension 3 has 4.40%. The chi-square test is testing the hypothesis that the total inertial value is or is not different than 0. So here, our significant or p-value is less than 0.05, which indicates our initial or our total initial value is significantly different than 0. So To interpret our our plot, so correspondence analysis plot should be interpreted by looking at points relative to the origin. Points that are similar directions, say for example, sandal and bath soap, are positively associated. Points that are on opposite sides and of the origin are negatively associated. Points that are far from the origin exhibits the strongest association.